we are looking at relations and functions. So the first thing here is a relation. A relation is a mapping or pairing of unit values with output values. So a relation can be represented in a bunch of different ways. The first way would be ordered pairs, where, just as a reminder, the first value is your x value or your input, and the second value is your y value or your output. We could also represent a relation in a table. So we could have a table of x and y values, and listing our ordered pairs there, we would have -2, 2, -2, and -2, 0 and 1, and 3 and 1. If we wanted to graph these values, we could graph them as ordered pairs or as a table. So we have -2, +2, -2, -2, 0, 1, 3, 1. Remember, x is your left and right, y is your up and down. And then we could also use a mapping diagram. So in a mapping diagram, your first oval will be your input, and your second oval will be your output. Okay, so your input values are your x values. So when I input -2, well, actually, let's go through and list our x values first. We would have -2, 0, and 3. And then let's list all of our y values. It should be -2, 1, and 2. And then for your mapping diagram, you are just going to draw arrows connecting each input to the proper output. So -2 can give you an output of 2. -2 can also give you an output of -2. 0 gives you an output of 1. And 3 gives you an output of 1. And that is how you'd make a mapping diagram. Okay, so just reviewing, domain is the set of input values and range is the set of y values. So what is the domain for the relation above? For this, you would use set notation, and you would just list all of your possible x values. So set notation of my inputs here should be -2, 0, and 3. And for the range, you are going to use set notation and list your output values. It should be -2, 1, and 2. Okay, if a value repeats itself, you only have to list it once. Okay, so that is relations. The difference between a relation and a function is a relation for which each input value has exactly one output value. If any input has more than one output, the relation is not a function. Okay, so we'll have both discrete and continuous functions. Discrete functions are functions that consist of separate points that are not connected, while continuous functions are graphs that are unbroken, and that would contain an infinite number of coordinates. So let's just take a look at number 1. We need to make sure that each input has exactly one output. So for number 1, -3 goes to 2. That's good. -1 goes to 3. Good. 2 goes to -4. 4 goes to -4. As you can tell, both 2 and 4 give you an output of -4. That is okay because they can have the same output. It's just each input can't go to multiple outputs. So this one would be yes. Oops. Is a function. But in our second example here, you will notice that 1 has multiple outputs. So since 1 has multiple outputs, this would be no, it is not a function. And the reasoning is 1 has 2 outputs. Okay? we'll save the last example for class together. So the last thing on this first page here is the vertical line test. Okay, we have used the vertical line test for a while now. Remember, if you can drop a vertical line through any point in a graph, that gives you a function. If you drop a vertical line and it touches multiple points, like in the second example, this would not be a function. So the next section here is notation for domain and range. So yes, you can write domain and range as inequalities, which is what we have been working on the last couple of lessons, but you can also write this in interval notation. So for interval notation, you have your different types of brackets. You have round brackets, which tells you that the value is excluded from the set. So that would be used when you have just greater than or less than symbols. Also remember, infinity symbols will always use a round bracket. Then we have inclusive values, which uses a square bracket. You will use inclusive values when you have a less than or equal to, or a greater than or equal to sign. Anytime you have an or, that is when you are going to use a union symbol. Okay, let's go through just a couple of examples. So if I have x is greater than 5, I know that 5 is going to be the lowest number I can have, and infinity would be the greatest. So in interval notation, I would use a round bracket, 5 to infinity, because this lists my possible outcomes. If I was to switch that to a greater than or equal to sign, all I would change is I would use a square bracket and write 5 to infinity. Okay, skipping down to one of the compound inequalities. If I have 4 is less than x is greater than 4 and less than 9, I would use a round bracket to represent the 4. And I would use a square bracket to represent the 9, because it's or equal to. Once again, going down to this last one with the union symbol, I know that x has to be less than 5, so that would be negative infinity to 5, or x has to be greater than 8, so that would be 8 to infinity. And it's greater than or equal to, so I'm actually going to have to switch that to a closed bracket. Okay, let's just go down and do one of these ones. So in these problems, they want us to identify the domain and range and tell whether the relation is a function. If it's a function, identify if it's discrete or continuous. So for number 4 here, remember our domain is our possible x values. So within this function, any x value would be true in both directions forever. So you could write all real numbers as your domain, or in interval notation, we could write negative infinity to infinity. And with range, that is our possible y values. So as we continue in either y direction, since this graph goes on forever, although it won't go positive or negative in the y direction very quickly, it will go forever. It's the same answer. All real numbers, or negative infinity to infinity. Next is asking, is the relation a function? Well, this is where you could use the vertical line test. Anywhere within this graph that you dropped a vertical line, it would only touch the function at one point. So yes, this is a function. And then finally, is this discrete or continuous? Remember, discrete graphs is where you have a collection of points, where a continuous graph is where you have a line. So this graph would be continuous. Okay, we'll do the other two examples together in class. Same with our linear function. We'll do that in class as well. All right, please try the other two examples that I didn't get to, and come to class with any questions. Thanks for watching.